Hey, welcome everyone. This is Paul Deffenbaugh from Metal Architecture Magazine. Glad you joined us today for our webinar on understanding pre-painted metal. It's presented today by Steelscape. In just a moment, I'm going to turn things over to Michelle Vondren. She's our speaker today. But before I do that, I want to cover a couple of things too. First, for those of you who need AIA credits and/or certificates, everything's going to be handled automatically. You don't need to do a thing. Just allow us 5 business days for processing. I won't put them on the spot, but the person who handles this is incredibly efficient, so it often is much sooner than 5 business days. Second, we'd love to get your questions during the webinar, and you're going to want to take advantage of this because Michelle's got just a vast pool of knowledge to draw from. We'll take questions at the end of each section and at the end of the webinar. So post your questions on the panel on your screen and I'll raise them with Michelle. That covers the credits and certificates reporting as well as how we're going to handle questions. So let's get to the good stuff. Michelle Vondren is technical manager for NS BlueScope Coated Products North America. She graduated from California Polytechnic State University in San Luis Obispo, and she did that with a Bachelor of Science degree in chemistry. She started her career as a research chemist with Morton, that later became BASF Coil Coatings, and with a focus on polymers. And that position also included lab development as well as lab to production scale up and manufacturing quality and process control. Eventually, she shifted to cool pigmentation, where she brought the first cool coil coatings to market. Michelle's active in the Cool Roof Rating Council and Energy Star Roofing Program. She joined Steelscape as a quality engineer for the Rancho Cucamonga, California paint line. While there, she has held the quality systems manager role, and she's now the technical manager, as I said earlier. Michelle oversees the quality systems and technical service for BlueScope Coated Products, which comprises Steelscape and ASC Profiles. She's an active member of the National Coil Coaters Association. She sits on the technical committee there, and she's also active in the Zinc Aluminum Coaters Association. Michelle's a great source for our magazine, so you'll see her name often in metal architecture and metal construction news. All right, Michelle, as they say on Star Trek, you've got the con.
Thank you, Paul. Paul always does the best introductions, and I feel like now the bar is very high and everyone's expectations are high of me. So thank you for that. Welcome, everyone. We have a lot to cover. There's a lot of content in this. As Paul said, we will stop at the end of each section to do questions quickly. So we will jump right in. So the information about your credits, covered that. These are the 4 learning objectives today. We're going to go through the kind of pre-painted metal fundamentals, the paint application process, and a little bit about the substrate so you understand where the product starts at. We'll talk about the 3 most common types of paint systems that are used in the coil world and their differences and appropriate applications. We'll spend a little time talking about enhancement options on the painted side of the business, how we can modify, deal with special environments, things like that. And then at the end, we will wrap up with durability and performance topics and warranties that we see out in the field. So what is pre-painted metal? Quite self-explanatory. These are rolls of metal substrate, either coated steel or aluminum, has its paint applied and is baked on and then coiled back up again. The coils then go downstream to get formed into pieces and parts, building components, mostly roofing and wall panels, but can be used for other things as well. But not all pre-painted metal is the same. Not all the paint systems are the same. Here's just a quick highlight of where coil gets used. Our focus today is exterior building products in the construction world, but this process of pre-painted coil is used for HVAC appliances, cabinetry, hot water heaters, window frames, door frames, metal furniture, a lot of other applications as well. So quite a lot of markets that we deal in. So our first question to start off, how is paint applied to metal for the majority of building applications? Is it an air brush technique? Is it a dipping process? Is it rolled? Or is it a straight brushing process? And the answer is it's rolled on, but not like the rolled on paint most of us are familiar with and have done maybe in our house or around our property. So picture here of a coil coating line. These are very large roller applications. The strip is moving and the rolls with the paint on it move in and touch the strip. This is kind of a generic schematic of a paint line. They all vary a little bit in layout and design, but they all do the same thing at the end of the day. So it's a continuous process. We load one coil, we get to the end of that coil, we mechanically attach the next coil to it so we can keep running continuously. So it's very quick. The paint is applied and baked on literally in a matter of seconds. Most of these paint lines are running anywhere from 100 up to 700 feet per minute, depending on how new they might be. The curing process for the paint, so the time the paint touches the strip until it is completely cured and dried is anywhere from 15 to 30 seconds on average. So very, very fast. Very thin film too, which we'll talk about further in the presentation here. So by comparison, we use automotive coatings a lot to compare to the coil world. A car these days, to coat a whole car, 30 minutes to 2 hours. You know, we can produce enough coil in 20 minutes off of one of these coil lines to do multiple large metal buildings or roofs or wall installations. So very, very different. It is the fastest and thinnest coating process in the industrial coatings world or space. And if you want, you can go out like to the NCCA, which is the National Coil Coaters Association that's referenced here, or you can just Google. There's videos. You can see what these lines look like running. These schematics don't do them justice. I mean, they're very large. At the Steelscape plants, our accumulator towers are 8 to 9 stories high, so quite large. Because of this size and how fast this runs, there's a lot of advantages to this process, right? We're cleaning the surface and treating it prior to the paint being applied. It's a very controlled environment, so we have great reproducibility, not only in our film thickness, but in our color control, which is very important in the architectural space. That, you know, if I run, you know, colonial red today and I run it 2 weeks from now, it's going to look exactly the same in color and appearance. Very efficient use of paint. So we're putting this on about 1.4 mils total of paint, and that includes the primer, the top coat, and the backer. By comparison, most industrial coatings are like 2 to 5 mils in thickness. Paper is 2 to 3 times thicker than the paint we're putting on this material. And now keep in mind, this paint now has to go downstream and get fabricated, rolled or stamped into a final form or shape. So the paint has to be able to withstand that process as well. So very specifically designed and formulated for that, with a wide range of characteristics depending on where it's going to go in its final installation. These are solvent-based paints, but we use closed loop systems on these lines. So the ovens are burning those solvents off to cure the paint. Those solvents are captured, oxidized through an RTO. The heat generated from that is pumped back into the ovens to fuel the ovens. So all the VOCs are being captured, and the final product is VOC free at the end of the line. Now, because of the size, the scope, and how fast these lines run, there's some trade-offs, right? There's some limitations to that. Very rapid. So, you know, we want to set up and be able to run for a long time too, right? We don't want to have to be doing a lot of paint changes, short runs, not very efficient on these lines, problematic. So, you know, that's why most panel manufacturers have kind of a set color palette that they like everyone to choose from. I mean, we can do custom colors, but it's difficult, becomes expensive and time consuming. These lines on average hold anywhere from 1,000 to 3,000 linear feet of steel from one end to the other. We like to not run orders smaller than that. So, you know, if someone needs 1 or 2 sheets of a custom color, this is probably not the process for that. Again, quality control, really important because of what's going to happen to this product before it gets out onto a building. So we do what's called T-bin test and impact testing. That is to simulate the forming that this material is going to go through to become a roof panel or a wall panel or a component on a building. We want to make sure the paint's not cracking, that it's forming the way it should. Color, huge, right? Color control. We do that numerically and with computers as well as visual comparisons to a controlled standard. Gloss is important, right? That shininess of that surface is critical and is specified for every paint formulation. And then, of course, our film thickness, again, very, very tight, very small thickness of film. We control that to 0.10 mils of thickness. That's the range we have to hit on all of our paint specs. And that film thickness is critical not only for the appearance of the product, but the long-term performance and warrantability of the product as well becomes crucial. So before we dive more into paint, though, I do want to talk a little bit about the substrate underneath, because it is a very important part of the whole package here. So most coated steel is either galvanized, hot dip galvanized, or an aluminum zinc alloy, the most common being Galvalume or Zincalume, the two trade names you might see out there in the market. That's a 55% aluminum zinc mixture. When you add aluminum in with the zinc, you get enhanced corrosion protection and performance long-term versus straight hot dip galvanized, which is 100% zinc. That 55% ratio, a lot of research done many, many years ago to come up with that, and it is the optimal ratio. Reminder that Galvalume and Zincalume are registered trademarks. To call your product either one of these names, you do have to have a license to do so. So again, the aluminum is inert. Most of us know that. It has great corrosion protection, so it provides kind of a protective barrier, while the zinc provides a sacrificial barrier and will sacrifice itself to protect the base steel and iron underneath it. And again, the BIAC licenses coaters to use this technology. If you ever want to check, you can go to their website. It does show everyone in the US that holds a license for this product, so it's public knowledge. Your installation environment and the type of building and where it's located may dictate which substrate you want to use. For example, for animal confinement, hot dip galvanized is the choice. For marine locations, you're probably going to want to go with a Galvalume, Zincalume, or straight up aluminum substrate to hold up to the salt water and salt air that it'll be exposed to. Okay, so now we can jump into paint. Look, we all know what paint is, right? I don't think I need to lecture you on that, but we're going to talk specifically about what this type of paint is in the coil coating world for exterior buildings. But it does basically the same thing as any household paint, any paint you buy, decorative paint, artistic paint, right? We want it to protect the surface and we want it to look a certain way, right? Aesthetics is incredibly important and one of the driving factors, but it's also got to perform. So our paints have four primary ingredients. We have the resins or the polymers. That's the binder of the paint, kind of invisible. It determines the primary physical and chemical properties of the paint system. Pigments, right? That's all about color 90% of the time, but we will see that pigments also bring some other attributes and performance characteristics to the table as well. Solvents. There are no solvents, like I said, in the final product. That's all burned off during the manufacturing at the coil coater, but that solvent ratio is important. We need these pigments and resins to stay in solution properly, while they're being transported in the drums. It has to be a consistency that the coil coater can pump out of the drum into the coater head. Easy cleanup, and it's got to be solvents that are not terribly dangerous to either people or the environment as well. And then there's additives. We kind of joke that the additives are the magic fairy dust that paint suppliers put in their formulas, and that can be anything, from fine-tuning flow and appearance to subtly adjusting gloss. There's a wide range of additives, but they tend to be a very small component of the overall formula. So if we look at, these components, this is kind of what they bring to the table, kind of a nice little cheat sheet here. So the resin, again, is really the workhorse, the backbone of the paint system. It's doing the heavy lifting, so to speak. So durability, hardness, flexibility, adhesion, gloss, chemical resistance, corrosion resistance, humidity resistance, all of this stuff is coming primarily from the resin or the polymer. And then your pigment, again, your color. You want to hide the surface that you're putting it over. It does bring corrosion resistance to the table as well. And then film strength and water resistance can be enhanced with pigment choice. And again, the solvent is really about viscosity and handling during the manufacturing. And it's got to be stable. You know, these paints have a shelf life of 6 to 12 months, and that's due to these solvents and how they're formulated, that they stay good for that long. And we got to be able to burn those solvents off, right? Almost all of the solvent flash off occurs right up front in the ovens on these lines very, very quickly. So that ratio is important for that. You don't want it lingering around. So again, here's the kind of the ratio, right? The resins, solvents, pigments kind of equally divided, 30, 35%, and then a little bit of additives at the end. And this is by weight, not volume. So how do you know what paint to select? I mean, we talked about all the different end applications for this type of product, and that will play a part in the balancing of paint properties, right? So you need it to be soft enough and flexible enough to get formed into a panel or a part, but you need it to be hard enough and resistant enough to, you know, hold up to scratches and handling. And the actual installation process itself, you know, on a building can be quite harsh, right? Things are getting drug on it. The installers are walking on it. You know, it's getting stacked on itself. So you got to balance that out. And this red line here kind of represents where most exterior coil coated product ends up falling. It's a little bit to the hard side. So it resists chipping and cracking and all that good stuff, but still has enough flexibility that most of these coatings, you can actually bend a piece of coated metal completely back on itself without these paints opening or cracking on that bend. So pretty good flexibility, even though they're also hard. Pigments and color. This is the fun part. It's always fun to see what colors you architects have come up with and how you put them together. I'm fascinated by that. I'm not terribly creative. I'm more of an analytical mind. So I know when we get orders that come in that are just kind of these crazy colors, and you go, oh, I so want to see where the final installation is for this and how it's going to look, because it's pretty spectacular sometimes. We have two different types of pigments primarily that we deal with. We have organic and inorganic. Inorganic pigments are your duller earth tones, yellows, reds, greens, browns, and blacks. They are iron oxides primarily, or some kind of metal oxides. These are mined out of the ground and then further processed to be used as pigments. Organic pigments, right, are your really bright primary colors, reds, blues, greens, and violets, that are beautiful but don't hold up so well under the sun, right? We've all seen faded red cars and brightly colored things, and we know that they fade very quickly. So yeah, we don't use a lot of organic pigments. Bring them in very small quantities to get the right shade, but the inorganic pigments are going to give you the long-term durability. I like to talk about color real quick. I mentioned how we QC color. We do it numerically. We have color control instruments on the lines that are measuring color and giving it numerical values. We read the 3 scales: light, dark, blue, yellow, green, red. We're looking for a very tight tolerance. We typically run within a plus or minus 0.5 unit of any one of these 3 scales. That is less than what the human eye can detect. The human eye really doesn't pick up color difference till you get to a difference of 1 whole unit or more. So we're operating underneath that. There's still also a visual, there's a little bit of art to this. There is a visual component, right? We have a standard or a color that someone selected. And you know, regardless of what the computer tells us, it visually needs to look correct and good as well. We do color blind test our operators. That question has come up before, but yes, that is one of the qualifications to work the QC lab on a paint line, is to be able to see color properly. So there's a lot of different layers of the paint too in this process. That's important. So we have our metal, our substrate in the middle there. We have a very thin layer of pre-treatment that goes on. That's prepping the surface for the paint to adhere to. We almost always have a primer. I would say 90% of the time there's a primer. The primer is really going to give you a lot more corrosion protection, and then provides a lot of what we call bite or sites for the top coat to cure to and bond to for long-term performance. Then you got your top coat. You may or may not have a clear coat over that, depending on the needs, and we'll get into that in the enhancement phase. But for harsher environments, you might need a clear coat. For bright primary colors, we talked about organic pigments. If you want a pure red or yellow that's all organic pigmentation, you're going to have a clear coat, provides some UV protection to it. And then we also have a backer and a primer. So we coat both sides of the metallic strip, and we put a primer, the same primer that goes on the top goes on the bottom, and we do put a backer coat or what we call a wash coat on the bottom, and we'll talk more about that a little bit later as to why we do that. So any questions on that real quick before I...
We have a shy audience, but I do have a question here, Michelle.
Okay.
One of the listeners wants to know, are the finishes elastomeric enough to flex when they're dinged, like when hit by hail or sleet?
To a certain extent, yes. I have seen many a hail damaged roof where the paint has not cracked or opened, but there is clearly an indentation or deformation of the surface. It depends on how big, right, a piece of hail or whatever the debris is that hits it. And then also the sharpness, right? If you have like really sharp hail with ragged edges, you might actually scratch or cut into that coating if it hits with enough velocity. But yeah, you know, pre-painted metal actually holds up really well to hail compared to a lot of other roofing substrates. But I've seen some pretty bad hail damage too that, you know, when you get into the golf ball size stuff, you're probably going to have damage, right? If it's cracking windows and car windshields, it's probably going to cause damage to the paint on a roof too.
And I think you're going to cover this later. A couple of questions about repairing pre-painted metal and issues like that. Should I just wait, hold those?
Yeah, let's hold that till the end when we talk about warranties and performance in the field. And if I don't remember it, someone prompt me. That's a very good question, and it is something that we have to deal with. So yes, good one.
Let's continue then. Thank you.
Okay, so now we're going to get into paints a little bit more specifically, and there's going to be a little tiny bit of chemistry, not much, I promise you, and there will be no quiz on it. So what are the three common paint systems used for building applications? We have polyesters, we have silicone modified polyesters, or SMPs for short, and then we have fluorocarbon or PVDF, also known as Kynar. Also has about 5 other names that we'll cover. I don't know why we have so many names for the same paint, probably just to confuse everyone, but 3, polyester, silicone modified polyester, and fluorocarbon are the 3 chemistries that we see predominantly and that we're going to talk about today. These are kind of listed in order of good to best, is how we think of them. Again, fluorocarbon, this PVDF family, polyvinyl diene fluoride, that's as much chemistry as I'm going to give you today, is the actual chemical name for that, also known as Kynar 500, Hylar 5000. A lot of you will be familiar with seeing Kynar or PVDF called out in the architectural specs, used, you know, for monumental buildings, big commercial applications, government projects. So we'll start with polyesters though, and you know, polyesters are a great paint system, a huge range of options for formulation and performance. So there's more polyester formulas than anything else out there in the world. Can be really cost effective, can have phenomenal flexibility, the best flexibility of any system. So you do see it on applications where you need really tight bends, mostly for interior applications. Wide range of colors and gloss. See it for low-end metal roofing, gutters and downspouts, rainwater goods is almost all polyester, some ag and light commercial. Used extensively for appliance wrappers and electronic goods, housings and casings, things like that. Window frames, door frames, T-bars in your ceilings, that's all polyester product. And I like to make an analogy here for people to understand the world of polyesters. And polyester is a very specific chemical structure and reaction. So think about, we wear polyester clothing. We're also making pre-painted metal out of polyester. It's the same chemistry, but that's how versatile and wide-ranging that chemistry and family is that we can have everything from very nice clothing to an industrial metal coating that can go out into the elements. So kind of a crazy family of chemistry. Now, silicone modified polyesters are polyester resin backbones, polymers that have had some silicone reacted into them. And what happens when you do that is you get kind of a step up in weatherability and long-term performance. So you get better performance. You still have kind of a wide range of options for colors and gloss and performance. And it's a little bit lower price point and more economical than the PVDF we're going to talk about. So we see SMPs used a lot in residential and light commercial. And I will note here that the gap over the years in performance between SMPs and the PVDF, which is next, has shrunk tremendously over the last 20, 25 years. There used to be kind of a more clear, distinct performance between the two, and that has, it's gotten very narrow. So the fluorocarbons, these are the Cadillacs of paint system. PVDF, that molecule is one atom different than Teflon. So that's the family it lives in. Teflon's maybe easier for folks to wrap their head around about how durable and long lasting that is. This is a very much a first cousin, if not a sibling to that product. So exceptional chalk and fade resistance, does well in aggressive environments, marine environments, industrial environments, some great chemical resistance, but still has really good formability. So again, big commercial installations will have this product spec'd, pre-engineered buildings will have this spec'd into it. And this is kind of, we'll talk about enhancements, but any kind of like special pigmentation, special looks are almost always done in this PVDF formula, not the other two. I will mention, because it's become a topic in the last year, so it's not a presentation, but the supply of PVDF became really dicey the last couple of years and very critical. There was a shortage in the coatings world of this resin technology for a couple of reasons. One, COVID and a lot of production in China had to come offline as they dealt with COVID, but also PVDF, this particular polymer, is used extensively for lithium-ion batteries and electric cars. So as that demand has skyrocketed, the supply and capacity has not caught up. So there's been some shortages of PVDF. It's better right now, but the coatings world is kind of looking for other alternatives to it, because I think we all know that EV, that's just going to continue to climb exponentially in volume. So they're bringing more capacity online this year and next year to make this resin, but I think it's going to be in a catch-up position for a while. So for a lot of applications, the SMP that we just talked about, good SMP with really good pigmentation, its performance is really not that far off from PVDF. So we're trying to educate folks that if PVDF supply is an issue still, the SMP is a really nice alternative. It's going to give you a really good warranty and a really good product. So this is kind of a generic breakdown of the three together, all in one spot. Polyester, again, ranges from good to better. The warranties on polyesters can be anything from none to pretty decent, like, 20, 25 years. Durability is kind of all over the map, but very versatile. We got the AMA specs that govern each of these as well, listed at the bottom. Your SMP, right, really good performance has come up a lot over the years. Most suppliers now are using the same pigmentation they use in PVDF for the SMP product line as well, so it's comparable. Really good weatherability, used in a wide range of construction applications. And then, of course, the granddaddy, the PVDF. Best warranty, best performance. We'll talk about warranties a little bit later, but SMP warranties are anywhere from kind of 30 to 40 years these days, and PVDF is 30 to 45. I think there's some 50 years out there as well on that, but we'll talk about warranty language in more detail later. So things to keep in mind when you're designing a project or figuring out what you want to spec and use, right? Polyester is not all the same. So you can't just throw that term polyester out there and assume that everyone's on the same page, because it can be all over the place. The differential, again, between high-end and polyester and S&P has become marginal, and the S&P performance to PVDF has become very small as well. PVDF still offers the best UV resistance, though, for optimal exterior durability. Kynar 500 and Hylar 5000, PVDF is a trade name. You have to be licensed and buy their product to use that name. And then PVDF systems are almost always 70% of the overall resin composition. If it doesn't have 70% PVDF in it, you cannot call it Kynar or Hylar. So there are some rules around it. Any questions on that section? I know it's a lot.
Yeah, thanks, Michelle. Yeah, there are a couple of questions. Are powder coatings used at all in this process?
In coil, no. No. Powder coating is almost always done by what we call batch coating, right? So they're coating a final part that's already been manufactured. It's not a continuous application of coating. That said, you do see some of the same chemistry and technologies used for powder coatings and the same substrates used for that as we use, but two very different ways to get the coating applied.
And then one of the listeners is interested, what's the difference between baked enamel and polyester, or are they the same?
It's baked enamel covers pre-painted metal, regardless of what the paint system is. They all kind of qualify as a baked on enamel system. So it's an inert, thermally cured cross-linked paint system is an enamel. We see that term more around the PVDF paint systems, but everything we're talking about here would technically qualify as a baked on enamel paint system.
And one last quick question, is S&P coating good for a coastal application?
It's not recommended. Almost all the paint suppliers are still recommending a PVDF system for coastal, which we're going to talk about here shortly, with a special primer and or clear coat as well. So yeah, I mean, S&P could be okay at the coast, but it's not the preferred go-to.
Thank you. Let's continue on, and please continue to contribute your questions.
Yes, good ones. I like it. So yeah, now we're going to talk about enhancements and some of what we just covered here. So right, what are the building considerations that might be in play that are going to influence the type of pre-painted metal specified? And there's a lot, and we're going to cover the kind of the top ones here. Proximity to saltwater, marine locations, building energy efficiency, the type of color and look you want, the visibility of the roof, right? Do you see the roof from, what's that viewing plane look like? Are you interfering with other buildings? Is it in a flight path to an airport? That's a big one. Reflection of the roof surface. Using metal with other building materials, there's some rules around that and some words of caution around that. It can be done, it just needs to be done properly. Exposed eaves and overhangs, things of that nature. So talk about all those. Ones we're going to focus on here today in a little bit more depth are the specialty pigmentation, which is our micas and metallic pigments, nice sparkly, pretty pigmentation. Clear coats, what they bring to the table. Marine and industrial environments, graffiti resistance. Not only resistance to graffiti, but the ability to clean graffiti off. Cool roof, cool pigmentation, that's around Energy Star, Cool Roof Rating Council, and it's just in California, Title 24 codes. Textures, and then prints and imagery. We can do image work on this in this process as well. Micas and metallics, really popular, have been popular for years, especially on big high-rise buildings, right? We get that nice pearlescent or sparkly finish. Historically was actually done using metallic flake pigmentation, which is why we use the word metallics. True metallic paints using metal flakes have to have a clear coat for performance reasons. We don't see that a whole lot anymore. Almost all of this is now mica pigmentation, but the word metallic is still being used. So you get that sparkling light catching effect. There's also color shifting pigmentation available. You've probably seen that on cars more than on buildings, right? It looks purple from one direction. You walk around, it turns to green or blue, depending on the viewing angle. We can do that in the coil coating world as well. I don't know if too many installations. There's a few out there. Anyone in Southern California, the cruise ship building and pier in San Diego is a color shift coil coated installation. It's a turquoise to blue kind of shift. Very cool. Those, we see those a lot. Some words of caution around these. Micas and metallics are batch sensitive. So we cannot guarantee an exact color match from one batch of paint to the next, nor can we guarantee it from one production run on the coil line to the next. So if you're going to do an installation with one of these colors, that's fine, but everything needs to run at one time, or you could have shade variation. This becomes challenging if you're doing very large multi-phase installations, like we're currently doing an Intel project that's like 12 or 14 buildings that are all a silver metallic. A lot of material that has to be run at one time. But this is kind of what it looks like. So you can see the picture on the right is actually different batches that were mixed. And then the picture on the left is they are directional. So the orientation of that panel makes a difference on how the color appears. And if you flip 180 by accident, it's going to show up as a different color on the job site. Extreme environmental enhancements. We can modify these to get some warranty and performance. The biggest one is marine or coastal locations. Again, typically you're going to use a high build primer. So instead of the typical primer that's about 0.2 mils of film, you're going to go to a 0.8 or a 1 mil thickness of primer. It's going to give you extra corrosion protection. You may also need a clear coat in addition to that, just to hold up in that environment. So these are usually 3 or 4 coat systems. Has to go back through the paint line more than once to get all that paint applied to it. So there's some cost there, but you can get a warrantable product doing this. I think almost all the paint suppliers right now offer a marine paint system of some sort with a 15 to 20 year warranty in proximity to salt water. Now, the caveat to that is that everyone's definition of marine differs a little bit. It can be anything from within 1,000 feet of breaking surf. It may be 1 mile from salt water, depending on the supplier that you're working with. So always good to follow up and say, well, what's your definition for marine, right? I would say if you are doing any installation that's within 1 mile of the ocean, you need to be talking to your supply chain about whether they consider that an extreme environment or not. Clear coats and graffiti. So we talked about clear coats adding protection in marine environments. They can bring, they're basically like sunscreen. So there are actually kind of clear translucent UV blockers in these clear coats that help protect the coating underneath it. If you were to look at them by themselves, they actually have a slight yellow tint to them. Because of that, they're not completely translucent, 100% clear. So we use those over organic pigmentation when it's needed. It can also be used to add enhanced gloss, get you a little bit more perception of depth on the coating by using a clear coat. Food staining and food contact, and then graffiti resistance. So there are clears out there that not only does graffiti or other coatings not stick well to them, if something does stick to them, they clean up very, very well. So that's an option and an enhancement that can be ordered. Again, we're talking about the color variation. So these clears, like I said, have a very slight yellow tint to them, which means that on a lighter color, like a white or a light tan, once you apply that clear coating, you might see a slight shift in the visual color. You're not going to see it on medium and dark tones. It'll be kind of, can't pick it out of the lineup. But we have some examples here. So the panels on the left are standard primer, standard top coat. Panels in the middle have a high build primer underneath them. Panels on the right have the high build primer and the clear coat. And you can see that the white does shift a little bit in visual color. So just something to understand if you say, hey, you're picking a color off someone's color chart. So I really like that color, but I need it with a clear coat. Understand that that visual is going to be a little bit different they should be able to provide you a sample of what that looks like, so you see it ahead of time. Backers. The backer coat on the underneath of the strip doesn't get a lot of love, but it's quite important. It's kind of right out of sight, out of mind in most installations, and overlooked. Usually a neutral color, an off-white or a light gray. That said, I should mention we can coat full coat color coats on both sides of the strip at the same time if that's desired. We put this backer coat on here, one for corrosion protection and for any overhangs or eaves where you might see it, so you get a nice uniform appearance on that back side. We also do it because if you were to wrap, so you paint the top side only, you left the bottom side the bare metal. When you wrap this back up in a coil form and then unwrap it again, that bare metal side will scratch and mar the painted surface that it's in contact with. So we do it for protection while it's in coil form as well. Cool colors, cool pigmentation, right? Kind of the norm now, introduced back in the early 2000s. This is pigmentation that's been modified to reflect in the near IR region of the spectrum while maintaining its visual spectrum as to whatever color you want it to be. So blacks and browns that still look black and brown but are reflecting more IR, they stay cooler in the sunlight, your building stays cooler. A lot of building codes now around this. Again, it's in the LEED spec, it's in Title 24 here in California. The CRC regulates this, keeps us all honest to make sure that the solar properties we say our coatings have is legit. So how is cool measured? There is a lot of terminology out there that can get a little confusing at times. So we have solar reflectance, that's the amount of solar radiation reflected off of a surface. We have emissivity, the amount of heat a surface can dissipate away from itself. Take those two values, do a big old gnarly calculation, get solar reflective index value or SRI value, which is what we see in the specs a lot now. And there's an airflow consideration with that. Again, reviewed by the Cooler Ratings Council as a third party. Most panel suppliers will have their SRI values on their color cards as an example here, along with LRV, which is the light reflectance value, which is different, right? That's just about kind of color space and how much light the surface reflects. It's nothing to do with its cool properties. I see I get a lot of confusion. Well, you know, I need an LRV of 10 and that's not high enough because I'm trying to get cool roof stuff. And you're like, no, you're confusing your terminology. Again, you guys are, I'm sure a lot of you on the phone are more intimately familiar with LEED than I am, but I believe this is the current requirement. So it is by low slope, steep slope. Low slope kind of only can get to this 82 value with white. Nothing else really qualifies. Steep slope 39, that allows you to play kind of in the range of colors and lighter. But you know, lighter the color, the higher the SRI, even with cool pigmentation. That still holds true. Gloss and sheen, again, two terms that sometimes get confused with light reflectance and solar reflectance and other properties we talk about. You know, this is the visible shine off of a surface measured at a specific angle. So gloss is the measurement at 60 degrees. Sheen is the measurement at 85 degrees. High gloss and sheen is going to be high glare, high shine off of a surface. Low gloss surfaces, low sheen surfaces will have a very matte or flat appearance. Seeing a real move to that over the last 10, 15 years to lower gloss, lower sheen. You know, I personally, as much as I love our product, I don't want a neighbor who's got a very shiny high gloss roof that's blinding me through my windows, you know, when the sun hits it in the morning. So that glare component, that gloss component is important, especially for residential. And there's been a lot of restrictions on gloss and sheen and light reflectance around military installations and airports for a long time, because obviously we don't want our pilots unable to see well as they're trying to land or take off. So the way we do this, the way we drop this gloss and sheen is a couple ways. You can add some texture to the paint, right? That breaks that light reflection up. And you can do that chemically, or you can actually add particles to the paint to make it a rougher, kind of a sandpaper-like feel. or you can put flattening agents in. So you can put an additive in that kind of kills that gloss, gives you a matte finish. Doesn't affect color, doesn't affect SRV or SRI, two separate components. So these panels here that we have here, this is what we call an ultra matte finish and then a standard black. They are actually numerically the same color, believe it or not. They have very similar SRI and SRV properties, but you can see visually that their gloss and sheen is vastly different from one another. They also have the same LRV. They're in the same color space. This is some of the imagery and print work that can be done in a coil coating application. So Steelscape does roll printing or flexographic printing. You can also do digital printing now, or it's kind of like a giant inkjet printer that goes on the line. But we can do these kind of patina, rusted patterns, brushed, kind of the sky's the limit on pattern. We use the exact same paints to do this. We put a base coat down, like a solid coat down, and then we have a laser etched roll that we put a different color paint on that gives you this contrast in a pattern. So, pretty popular of late. Here's some of the imaging that gets done. This is a picture of laminate. So this is actually like a photographic coating that gets adhered to the strip. I see a lot of this in Asia. It's mostly for interior applications. It doesn't have fabulous exterior performance long term. Film bond's not as tight as a painted product, but you see it a lot for like faux wood finishes in doors, garage doors, column wraps, things of that nature. And again, digital printing, which is relatively new in the coil world, pre-painted metal world, is just coming online. And that's kind of nice because you don't have a repeat. You can kind of do as big an image or small as an image as you want. And we're all starting to play around with this. It's interesting to see where it's going to go. Hey, any questions on that? No, we're getting
thanks, Michelle. We got a lot of questions. It's got about 10, 15 minutes left here, so I want to be careful how much we jump into this stuff. But one of the questions from the audience is, and you mentioned, I'm going to combine two questions in one. The mica causing directional problems if it's laid in the right direction. Is that a problem with any kind of paint, but with mica additives? And associated with that is, how do you control batch color issues?
So yeah, the directionality is primarily an issue with the mica metallics. It can be an issue with the print patterns and stuff. I don't want to talk about that, but just straight solid color, yeah, mica metallics only. The only thing we can do to try to control it and get consistency is on the paint manufacturing side, right? They got to adhere to a pretty strict formula in way that they make paint and disperse the pigments. On the application side, it's about trying to have the exact same, what we call coater head setups, that your pressures are the same, your roll speeds are the same every time you go up on that particular paint, but there's still no guarantee that it'll look exactly the same from batch to batch or run to run. And then the directionality, right? We actually do put a lot of lines will print directional arrows on the back side, so that as it goes downstream through the manufacturing process, the panel manufacturers have that reference to know what direction the strip or the panel should be oriented in. They'll also put strippable film with directional arrows on it before it goes out to job sites to get installed, so that the installers have that reference for direction as well. And that helps eliminate a lot of these issues.
Great, thanks. I know there were a number of questions having to do with chalking and repairing damaged paint, and that's the next section. Why don't we jump into that?
Yep. Okay, so next question, right? What are the three elements that are typically covered by a warranty for this product? You may have metallic coating, you may have some corrosion warranty that comes with your substrate, depending on what you're using. But when it comes to the paint, we're looking at film integrity, chalk, and fade. And film integrity is, does the paint stick? Does it stay on the strip long term? So again, these warranties can be anywhere from 5 years to 40 years, 45, 50 years now. In some cases, we're seeing It's going to warrant against excessive chalking, excessive color fade, and delamination or failure of the top coat or primer to the substrate. These failures can occur for a lot of reasons. It could be due to improper application or installation. It could be a bad paint formula. It could be that, me, the coater, didn't apply the paint correctly and meet the right specs. It could be due to the environmental conditions the coating's been exposed to after installation. So this is an old photo now, right, from '81, but just showing back in the day, same initial color, several different types of paints here, the Kynar 500 and acrylic, which we didn't talk about because no one uses them anymore, polyester, and then silicone polyester. And you can see, in that 14-year time span, how badly some have faded versus the Kynar 500, which still looks almost identical to the day it was installed. So kind of the performance differentials we used to see. Chalking is kind of exactly what it sounds like. So chalking is when the resin or the polymer system has been degraded due to UV exposure and starts to break down into smaller bits and pieces that come loose, bringing pigment with it off of the coating surface. And it feels like chalk. It looks like chalk. It's kind of a white surface. You can run your hand on it. Your hand will come back covered with white powder. Don't see this very often anymore in modern paint formulas. Kind of rare. But there is a scale. There is an ASTM standard that helps you measure the degree of chalking on a scale of 0 to 10. The higher the number, the better. 10 means you have no chalking. 8 means you have very little chalking, so forth. Color fade, right? We've all seen this. This is again from UV attack of the pigmentation. We measure it by a delta E. That's a total calculation of the L, the A, and the B color scale. That's what will be spec'd in the warranty. It will say, for 20 years, will not fade more than X number of delta E units, whatever that is. Again, the human eye starts to pick up that change between 0.5 and 1 delta E. PVDFs are going to have the tightest fade number for their duration, so very little fade. I wish these photographed better. This is a series of panels I have that are very old that show the top there, the blue and the red is where the color started at, and then you have 5 units of color change and then 7 units of color change. So you can kind of see visually what that looks like on a dark color. Lovely picture of a roof there with a striped roof. We call those candy cane roofs when we see them. You see just some panels that have faded or some that haven't on a roof. Likely cause is either they've intermixed paint systems, right? So they have a poly and a PVDF on the same roof, or an S&P and a PVDF on the same roof that are weathering differently. They've used different paint suppliers and mixed them on a roof. Or it could be due to film thickness. The faded panels there may not have been in spec for film thickness and therefore are degrading quicker than the material that was in spec. So a lot of root causes for why we'll get fade. Most people, especially long-term over 15, 20, 25, 30 years on a building, if the fade is consistent across all the panels, kind of don't notice. No one's the wiser, right? It's when you get this differential, you might have a batch of panels that are fading quicker than others that it's going to stand out and becomes a warranty claim. I like to throw in here, because everyone likes to use automotive coatings as the end-all be-all of coatings, and they're very good coatings technology, don't get me wrong, but so we're putting these panels out on buildings forever and expecting them to perform. I've talked about they have very little coating on there to begin with, 1.4 mils total, which is less than what a car has. Exposed to the elements 24/7, right? They don't get to go in a garage, they don't get sheltered, they probably get very little maintenance or cleaning. By comparison, the average car warranty for your paint finish is only 7 to 10 years on your car. And we're talking 20 plus years of warranty on this type of material. Pretty big difference. Excuse me. Okay, so delamination or film integrity, the other thing that's covered under warranty. This one gets really tricky. This is loss of paint adhesion either to the primer or to the substrate. You can get visible bubbling, peeling, cracking, chipping, cracking, however it presents. There's, I've listed like the top kind of 5 reasons this happens, but there's about a million other reasons why you might get delamination of a paint system after installation, which makes this one a really hard one to investigate. But the common ones are low film, maybe an incorrect pretreatment that was used, inadequate curing on the coil line. Maybe you had a formulation incompatibility between primer and top coat, that can happen. And then the other big one is mechanical damage. So scratches, you can see in this picture, there's kind of a vertical scratch or line next to each section there that's peeling. That was scratches that occurred during installation. And now you have an opening in the coating, and over time, water and ice and other stuff gets in there, and you start getting that paint peeling back from that scratch line. Other avoidable failures. This is a kind of, when we talk about using these pre-painted metal panels with other types of materials on a job site. Galvanic corrosion is a huge deal. So dissimilar metals in a corrosive environment, i.e. next to the ocean. You get these rust blooms like you see in this picture here. So there's a stainless steel fastener at each one of those junctions underneath. So the Galvalume painted panel is sacrificing itself to protect the stainless steel and corroding all the way through the base steel to red rust. Sealants, wood, metal shavings and swarf that occur from drilling and cutting on a job site. These are all things we need to look out for that can cause failure later on. Again, a little bit more on dissimilar metals because we see it a lot. Again, only happens in a corrosive environment. You can use stainless steel with this material all day long if you're not by the ocean. If you're by the ocean, it's going to be problematic, right? So we got more active metals, less active metals. The further apart on this list two things are, the bigger potential for this to happen. So this is a stainless steel light canister that was recessed through a painted Galvalume panel with no barrier between the two in direct contact for about 300 feet off the surf break outside of San Diego. So high salt air conditions. It comes in as a paint failure. It came in as, hey, my paint is bubbling and peeling off of these panels around this light. What's happening is corrosion is occurring of the substrate underneath. As that substrate gets eaten away with corrosion, there's nothing for the paint to stick to anymore. So yeah, the paint comes off. But the root cause is galvanic corrosion. Concrete, pouring wet concrete cement up against these panels without a barrier, you're going to get moisture intrusion and cause corrosion. Again, it causes the paint to bubble off and peel. Chemically treated wood, which often has copper compounds in them, which pre-painted metal doesn't like, can be an issue. This is a house on Maui. Corrosion was occurring underneath this upper deck only. We found out that that wood was copper treated, so it's leaching out as rain and stuff falls onto the roof below. Once you get out past this deck over here, no issue with the metal at all. Swarf and metal filings. So swarf, these are little debris particles left from cutting, drilling, sawing that has to occur on a job site. That gets deposited on the surface. If you don't clean them off, then they start to rust. This comes into me as a rust claim of the panels. It's not, it's these little pieces of metal on the surface that have now rusted and away, they're gone and have left a red or brown stain on the painted surface. Probably not going to cause the paint to fail, but it doesn't look good. No one's happy with it. It's an installation issue, contractor issue. And we do have a lot of bulletins and guidelines on how to properly cut, saw, drill, and clean up so that this doesn't happen. Wet stack corrosion or storage corrosion. This is corrosion that can occur in finished panels that are stacked and stored prior to installation. If they get wet and there's not a lot of good airflow between the panels and the bundles or the stacks, you will start to get corrosion of the substrate underneath the paint. It looks like these little tiny blisters, a little rough surface. A lot of guidelines available on how to properly store this so that it is avoidable so that this does not happen. Oil canning, not a defect per se, but something that's kind of inherent to light gauge metal roofing. Again, can be caused by a couple different things. The substrate underneath not being nice and flat or plumb. Thermal expansion and contraction, right, can contribute to this. How your fasteners are used and whether those panels are floating on the surface and through those attachments or not, or getting stuck. Using stiffener beads or putting styrations in the forming of the panel will help eliminate that. Lower gloss coatings, matte finishes will hide this as well. You just can't, it's still there, you just can't see it as readily. Optical illusion. So how do we avoid failures? And I'll talk about how we fix failures when they occur. So how to avoid them in the first place? Write paint specification for the environment in the building. Use a good coder that knows what they're doing. Use a good paint supplier. Don't mix batches or paint types. Use a good installer, a good panel manufacturer. It's got a lot of history, knows what they're doing, knows how to install properly without causing damage. And then frequent maintenance and cleaning, right? You would not ever wash or clean your car and then expect it to look the same 10 years down the road. Metal roofings are really easy to clean and wash down, so it should be done pretty regularly. Now, when failures do occur, because they do occur, couple things you can do, right? You can either replace or correct repair in the field. The option you go with depends on the type of installation, the size of it, how old it is. You can field paint this material. If it's in pretty good condition, doesn't have a lot of corrosion or other issues going on, it's just faded or it's chalked or maybe there was damage done and it needs to be repaired. There are some really good reputable field painters out there who do use an air dry version of the Kynar, the PVDF. So it's a very good coating. It's sprayed on, fairly tightly controlled. It's gonna be a little bit thicker film than the original factory applied coating was, but I've seen some repaints, field paints come out looking absolutely fantastic and spectacular. And again, if the substrate underneath is good, the rest of the building is still good, it can buy you another 10, 20 years of life out of these panels. So there are viable options. If there's a lot of corrosion or there's installation issues, then you're probably faced with having to pull material off and put new material on. But we try to not disturb a building envelope unless you absolutely have to. But unfortunately, it does happen. So there are solutions for fixes. The constructs of a warranty, I want to walk you through this real quick. I know we're at our time. It's really important that you read beyond the first paragraph or the title that says 40-year limited warranty, because you need to understand what's being warranted for the 40 years of the 30 years. How much color fade is being allowed? How much chalk is being allowed? So I can tell you what, I can look at two 40-year warranties. One may say you're not going to color fade more than 5 units, and then the other one may say you're not going to color fade more than 7 units. That's not the same warranty. You got to read the exclusions and exceptions, what's covered, what's not. Again, the definition of marine and industrial should be spelled out in the warranty so you know. This example here happens to be less than 1,000 feet from the coastline is what they deem severe marine. Someone else may say it's a half mile, someone else may say it's a mile. It should be in the warranty. So not the most entertaining reading, but they're usually only a page, so not too burdensome. Again, check the warranties, your specs, what does the downstream customer want, what are they anticipating, review it with the supply chain to make sure everyone's on the same page, and then look at the exceptions. Things like non-uniform changes that are the result of part of the building never getting any sunlight, not going to be covered by the warranty. If you don't ever do any maintenance, your warranty is probably void. Galvanic corrosion, not covered by the warranty. So you got to read through that carefully. Geographic too. A lot of these warranties have geographic limitations on them as well. So it's a good thing to check. So we're at the end. I know I'm not going to read this to you. You know what we just went over. Any questions as we're tied on time?
Thanks, Michelle. I've got a number of questions. I know people are going to want to jump off though before we get to questions. So before we do that, I wanted to tell everybody that tomorrow afternoon, 24 hours from now, you're going to get an email. It's going to have a link to a recording of this webinar. It's going to have a link to download the slide presentation. And Michelle may regret me saying this. It also has a link to email address for her, so you can contact her directly for more information if we don't get your question answered. But I do have a couple of questions here. How tight of a corner can you bend with sheet metal and not mess up damage the paint? Can you do 180 knife edge bend?
Yes. Yeah. Depending on the thickness of the metal and the paint system, yes, you can. We call that a 0T. You can absolutely get a complete 180 fold over. In what we actually see sometimes is that the steel or the substrate underneath will start to fracture and crack open before the paint does, which forces the paint open. But yeah, depending on the gauge of the metal and the paint system, yes, you can get that kind of tight bend.
Are there colors that tend to fade faster than others?
Yeah, right. Your darker colors, anything that's has to have any kind of organic pigmentation in it to get the desired color is going to fade a little bit quicker. So yeah, you know, blacks are going to fade quicker. Reds, blues, greens, the darker ones, yeah, they're going to fade a little bit more than, you know, the beiges and tans and that kind of thing.
I've got a question. Somebody's asking for a recommendation on a clear coat product, and I'm going to encourage them to just to email you and follow up unless you have something you want to share about clear coat products here.
Yeah, that would be best.
Okay, and could you address surface preparation, chemical versus mechanical blasting?
Oh, so our process, the continuous coating process, is always a chemical treatment. So we're painting fresh substrate, typically right off the metallic coating line or the steel line. All we're doing is washing it and then putting, you know, a light pre-treatment, typically sometimes hex chrome containing, sometimes not, but it's a chemical reaction. A little bit of an acid etching of the surface. In the field, if you have to correct something in the field or repaint in the field, they typically use, I call it sandblasting. They don't actually use sand. It's some other substance, abrasive substance, to get all the paint and coating off that's already on there to prep the surface for repaint. You can do it with pressure washing. If the paint coating has deteriorated enough that it comes off easily with that, you could use water as well.
Thanks, Michelle. You always do a great presentation. Thank you so much for taking the time to share this with us.
Thank you. Thanks, everyone.
If you want more information, you go to steelscape.com. Again, you're going to get an email tomorrow with links for the recording. Download this, Michelle's email address. CEUs and certificates are going to be handled automatically, so you don't need to do anything. Just give us 5 business days to process all that. And the final thing I want to say is we're doing another webinar in a couple weeks, May 4th, powder and liquid feed coatings for curtain wall and other architectural applications. That's it for today. Thank you, Michelle. You're always fantastic. And thanks to all of you for attending. We'll see you in a couple of weeks.
Okay, thanks. Bye.